So one reason to push to get any backlogs of submissions in is because things start getting interesting. There's a good bit more independent activity and hands-on. You'll notice at the top of module 3, the next two submissions have been posted. The first one, an assignment. I want you to download a simulated USB drive, and then we want you to download and install FTK Imager Lite. Now, FTK is an entire suite of forensic tools. However, and it's a commercial product. It used to be open source, but essentially FTK Imager Lite is an open source, offered free to the public for trial use kind of tool, and it's specifically devoted to data acquisition, in particular hard drives, right? So there are additional features and functionality, but the idea is to whet your appetite for the full commercial product. And you'll find that it's annoying. Some of the features and functionality that you would see and be able to touch and taste on the screen with the free product are not quite all there, or do not completely function unless you take it to the next level and then get the entire suite. So the idea is, they're giving away something free, but there's a marketing hook, and I want you to be aware of how that works. We are keenly interested in the data acquisition capabilities of this product. I make notice of the fact that there is a hash and there are screenshots inside the folder, right? So inside the resources folder, there are hashes, but I'm going to go back out there. And in one season, the free product didn't change version and the hash remained the same. In another season, one spring we had, it was significantly different and the hash was different. So I have yet to check that, but I'll make sure that what's in the resources folder is intact. In fact, let's take a quick peek at it now. Do you see the assignments and solutions folder, everybody? Can everyone see this?
Wait, what folder? Oh, yeah, I see it.
Resources. It's in the module 3 events and acquisition folder. This is incident handling, basically. The focus is DEFR activities. So in this module, you'll be performing the tasks. Now, you had a taste of this. You had a preview of coming attractions. At the end of Intro to Cyber, we ask you to do some things on a system belonging to Sydney Corinth. And we're taking that to another level. So you'll get more practice this time. There will be less latitude to screw up and do it over again. Because by the end of Intro to Cyber, if there were fumbles, you had a chance to gracefully recover and do it over again. You do have 2 submissions for this assignment. It is due by the end of this week. So by the time we expire this week, 11:59 p.m. Saturday, you need to be finished with the USB download. I'm going to check these to make sure they work. Let me do that now and see if it downloads. So it says no preview available, download. You're going to want to click download. Everybody see this?
Yep.
Yeah.
It is a VHD, which means that it's going to behave much like a connected USB drive. Once you download this, you're going to do something with it. and you'll connect it. Let's just go ahead and do that. I'm going to download that. It says it can't scan the file. It's too large to scan for viruses. Download anyway. That's what you're going to do. And it downloads. And with a halfway decent connection, it should be out of there. Should be on your screen in 5 minutes or less. Let's let that continue to run while we look at the image of the hash. That hash image should be the same. So the MD5 hash, if you have, everybody does have a tool, right? Everyone has a hash tool?
Yep.
Yes.
Okay. So now this part here, when you click, it should take you, let's see if the version is the same. Oh, surprise. So it's not unlike forensic products to get purchased by other companies. I wonder how long ago this happened. GRC software. We talk about governance, risk, and compliance. So this is another buzzword or acronym for whether or not your employees or the members of your organization, if you're a nonprofit or a government agency or a corporation, whether or not they are doing what they're supposed to according to the standards and policies and procedures. And the goal of a forensic platform in many cases is to ensure compliance, right? So in this case, it's the investigation portion, right? And I'm guessing that what they've done is, yep, they did. They snapped up. I'm not sure how long ago this occurred. That's really annoying. Let me see if I can work around this. So learn more. I don't want to learn more. Where's the exit? There we go. FTK Imager. So hopefully this is still available. Download the Imager. It would be a shame if the new company decided to lobotomize this thing. So this is the full forensic suite 7.6. That's the entire thing. I might do some homework on, no. Did I see something about South Carolina Port Authority? No. So yeah, this is a little bit of additional information about the full suite, underrated features and so on. It's good reading so that you understand how things have changed. It's not uncommon for companies to, all right, so last year was 4.6 after Xtero purchased FTK. They've spruced up the version. And in order to be able to download Imager, you have to do this. What you're going to do is you're going to fill out University of the Virgin Islands. And you're going to put your name. And for business email, you're going to list your UVI email. Does everybody understand that?
Yeah.
And for job title, you're going to say forensic apprentice. How's that? And I'm gonna say Forensic Mentor. I agree to their privacy policy and I submit, right? So they'll basically allow you to acquire forensically sound images of local hard drives, CDs, and DVDs, thumb drives, or other USB devices, entire folders, which would what we would call a sparse data acquisition, right? Individual files from various places within the media. So you could have like a network attached storage or a SAN, or you can't really grab the whole RAID volume, but you can grab entire directories, right? Or individual files from various places in the media. Contents of forensic images stored on a local machine or a network drive, hashes, and so much more, right? So I think I clicked submit, and it says should download, and now it's downloading. And so what I'm going to do, they want you to download something extra here, and it's about download this white paper. Oh, sure. Yeah, I'll download the white paper just to reward their willingness to share their open source product yet. So, so there's something that's loading down here. Now that they have my email address, they'll be sending links for that white paper. I'm going to go back to this form and capture the link for this form now that it's changed, and we'll update Blackboard right now. Okay, everybody with me?
Yes.
That was for the USB. That's not what we want to update. It's the FTK download. We want to edit. It's version 7.1. Yeah, it used to be access data. Access data was the previous owner. And it says, is this link a tool provider? That's Blackboard context. So I'm going to hash this now. Before I'm finished, I have this in downloads. So let's get an updated hash for everyone here. So here we have the 4.7.1. I'm going to it's the, where's my MD5? I thought I had SHA. Dang, nabbit. I think when I updated my, okay, so I'm gonna go out to Microsoft Store if you don't have this already. Oh, there it is. Hash tool. I don't know why it's playing hard to get. Everyone still with me?
Yeah.
I'm selecting MD5. This is just to make sure you have. Now, would this be valid in court? If this
I'm not sure.
if this were a criminal investigation and there was jail time associated, would MD5 work for a hash in order to validate your tools? It would not. SHA-1 wouldn't be valid. Okay. Let's calculate a SHA-256 just to demonstrate. And I'm going to go into downloads here and select FTK. There's the hash for SHA-256, 256 and 512, 384. SHA-256 SHA 384, SHA 512, and there might be one other. Are part of the SHA 2 standard. I'm going to copy this. So I'll put SHA 256 here. And there you have it. Let's do that for the other one as well. We'll calculate a SHA 256 for this as well. On the assumption that we want to be prepared in the event that any investigation progresses to the place where it could become a criminal investigation, or it could escalate to where you have to involve law enforcement, right? So this particular USB.VHD is designed to simulate a USB thumb drive. We'll show you exactly what's going on in just a moment with that. And there it is. I'm going to copy this. Now, what happens when you are getting ready to use the USB? What you're going to do is use the drive manager in your system. And first of all, let's presume that I just collected this evidence and this is authentic evidence. Would I want to take any kind of forensic action with this particular exhibit or artifact? What would I want to do with this as an artifact? If I had just collected this, let's pretend that this is a physical USB drive. Am I going to want to take any forensic action based on a physical USB drive? I'm going to restate the question. Do I want to work with the authentic evidence to begin any kind of forensic activity? Can somebody unmute their mic?
I'll say no. You got the copy.
Thank you, Ray. That's correct. You want to work with a copy. So I'm going to go ahead and I'm just going to go ahead and copy this. And if I were forensically correct about this, I'm going to put it in the temp folder. Everybody see what I'm doing?
Yeah.
Okay, so now I have a copy. Do I know whether or not the copy is identical to the one that's in my downloads folder? Do I know if this is 100% an exact duplicate of my original artifact?
Not currently.
Not currently, I do not. That is correct, I do not. I do not currently know. What can I do to make sure that it is exactly, it's an exact duplicate of the original artifact?
Check the hashes for both.
Check the hashes for both is correct. Thank you very much. So I'm going to do this again. I'm going to select the file, only this time I'm going into my temp folder. And I'm using, I just want to walk through this process. It's kind of a reflex, right? I want to use this notional physical hard drive. And now what I'm hoping is that the copy in the temp folder, not in the downloads folder, will match the hash so that I know I have a forensically sound, I have a match, right? Does everybody see? Up to this point, the two hashes match, right?
Yep.
So that means I have an authentically identical copy with which I can begin to take action. If this were a physical hard disk, I would lock it away in a evidence locker, and I would initiate, if this, you know, let's say I'm incident handling. Let's see if we remember let's see if you remember some of the stuff from Intro to Cyber. Let's continue to pretend that this is actually a physical USB thumb drive. Before I remove it from the office and I'm acquiring the data, this is data acquisition now. What would I do with that physical USB drive before I stored it? It has to do with documentation. That's your hint. I'll give you another hint. It has to do with chain. Chain of custody. So I start collecting digital evidence on the scene. I'm an incident handler, and if I'm collecting digital evidence and I start to acquire data as an incident handler, I'm going to preserve the evidence. How do I preserve the integrity of the evidence? I log the evidence on a chain of custody form, on an inventory form, right? And I establish chain of evidence and store it in an appropriate container as original evidence. And whenever I'm working with forensic methods, I'm never going to use the original. I'm always going to create a digitally forensically sound copy of that artifact, right? So what do I do with this temp folder? What's in the temp folder? For the purposes of your acquisition activities, you're going to connect the VHD to your client machine as if it were a physical USB drive. You're going to go into the show more options on the system name, my computer. I'm going to manage. I'm going to select disk management. I'm just giving you a preview of coming attractions here. I have several disks on my machine, but I actually have 2 physical disks on my machine. I'm going to connect this as if it were disk 2 in order to be able to work this. When I connect the physical disk to my machine to start working for forensic acquisition, what is one thing I want to do to prevent the corruption of the disk contents? What's the number one recommended method to prevent when you have a disk? Let's just talk hard drive, NVMe, M.2, SSD, traditional hard disk, external hard disk, I don't care what it is, physical hard disk. What one precaution do you engage to make sure you don't corrupt the data on that connection? I'll give you a hint. The word block is involved. For the hardware tool that's recommended, but there are software-based methods for the same principle. I want to write protect the disk. Hello? I want there to be a one-way connection, so I can't write changes to the disk. Does this sound familiar? Somebody unmute your mic and tell me you're still breathing.
Yeah, we're still there. You're
Yeah,
speaking about the hardware write block.
Huh?
Hardware write block.
Yes, hardware write block is preferred, but there are software-based methods that can accomplish the same purpose. We are simulating, we are using the methods and tools of Windows to simulate the same kind of process, right? We can't go out and buy a $200 write block or a $500 write block for each student. But what we can do is we can connect. If I click into here, notice the action menu changes. When I first open computer management and click on disk management, when I go to action, it was grayed out and it didn't show these options. So I clicked down here below this disk. And then when I went back to action, I'm going to attach a VHD. And notice, what does this say, everyone?
Read only.
Read only. So we're going to simulate the conditions of a write block scenario. And I know this is just a notion, right? But we're going to simulate, because I want you to walk through this. This is part of the criteria for, this is one of the things you're going to have to prove and submit for your solutions going forward, is that when you connect these things, you're connecting read only. I'll browse not to the, do I want to browse to the downloads folder where the original is, where the original artifact is? Not really. Now I know I'm kind of mixing it up, but basically I want to work with copies, always the copy, right? So I'm going to go ahead and connect a forensically sound identical copy of the original source data. And if this were a physical USB, I would write block or write protect the connection for the data acquisition, right? And again, I'm using these features to simulate the notion of a write block, okay? So now, when I connect, I have the USB that was on Sydney Corinth's machine. It was plugged into the USB port, one of the USB ports on Sydney Corinth's machine. And I should start to see some pretty interesting stuff at that point. This is before I even, now I'm not going to change anything or browse anywhere. I'm just going to close this. That's the stage that is set before you begin to work with FTK Imager and in Kali. You'll use two separate tools to extract data in a forensically sound manner to acquire the contents of the USB thumb drive. That's what the solution is about. And this is the preparation for that. So I'm kind of getting ahead and giving you a preview of coming attractions for what you have to do once you get to the solution, right? So now we're demonstrating tasks and steps you'll need to complete the solution. So once you have this in place, then you can perform a commercial data acquisition using FTK Imager. And then you'll also utilize an open source method in Kali. You'll use Geimager to extract the contents of the USB drive using Geimager. And from there, you'll acquire the data. This will set the stage for module 4, which is forensic analysis, right? For the forensic specialist. Not the incident handling side. Now, some of this, you know, would the incident handler do this if they were trained? And the forensic specialist had a huge backlog of, you know, forensic analysis to do on several different scenarios. It all depends on the scenario, but basically this is gray area. These are the types of responsibilities that could be performed collaboratively with incident handlers to preserve evidence. And, you know, it all depends on where the organization deems it's important to pass the baton, so to speak. It's also possible that the incident handler would capture the evidence, acquire the data, you know, create the chain of custody for the data, and then the forensic specialist would repeat the same activities, and compare outcomes with what the incident handler produced. Why would you be interested in doing that as an extra measure? Can anyone think of a reason why you would want the forensic specialist to perform the same tasks to acquire the data from the original artifact before beginning the analysis, the deep analysis, the data carving and so on, the disk carving and so on? Everybody remember the whole prove it, verify, validate, authenticate? You're always double checking.
Yes.
Okay, does that make sense?
Yeah.
Okay. How's the audio on your end? Is the audio garbled, or does it work?
No, it's good. It's good.
Audio's good? Okay. So you're not
Yes.
hearing any crackle or anything like that?
No.
Okay. Now, this is where you see additional information about the Geimager side of the acquisition, right? So this is a separate YouTube video, and then there's another one. You should watch both of those as you're engaging for the solution. Okay. Does everybody understand what we're doing here inside the resources folder for the next assignment and the solution? Now the solution is due. There are 5 additional documents and a YouTube, right, associated with. The assignment is due this Saturday before Saturday expires, 11:59 p.m. The solution is due by 9 a.m. Tuesday. So we want you to get started on it right away. Okay? Any questions before we begin our content review?
No questions.
Okay, so you'll notice some additional resources. Here is the U.S. Attorney's Search and Seizure Manual once again. So when you're dealing with incident handling and you're dealing with evidence acquisition, data acquisition, you know, it overlaps with evidence collection. And so that's a handy resource. The NIST Special Publication 800-101 Revision 1. We want to take a quick look at this. Guidelines on mobile device forensics, right? So handy reference when you're dealing with things like tablets and smartphones. And mobile device forensics would probably include USBs, probably, right? So when we look at the study guide, for Module 3, our student learning objectives include utilizing current research, identifying emerging challenges. That includes things like encryption. We want you to apply the notion of, what does SA stand for? Anyone? What does that acronym stand for? Okay, I'm going to find the nearest high cliff and leap from it, unless somebody unmutes their microphone. This is just review. SA stands for situational awareness. Hello? Repite usted, por favor. Everyone unmute your microphone one at a time. Let me see it. SA equals situational awareness.
SA equals situational awareness.
awareness.
All right, Luke.
SA equals situational awareness.
All right, Ray. Ray. Maybe Ray stepped out for a moment. Okay,
I'm here.
okay. SA means what, Ray? Situational awareness. Say it. SA equals situational awareness. Everybody,
Okay.
everybody else had to do it. I'm just asking you to do the same thing. Okay. This is, I mean, think of it as deep processing. I'm asking you to kind of parrot back the term because I want that to be, every time you see that, I want you to be keenly aware of what we're talking about there. A baseline to objectively identify physical and digital artifacts of interest, right? So we're going to have an office machine, the workstation owned by Sydney Corinth, except we're taking this scenario to a whole different level now that we're in digital forensics. So you had a taste of this once again in Intro to Cybersecurity, right? Tool integrity. You just witnessed one of the challenges of tool integrity is that forensic utility and forensic suite companies are often purchased by others. There's a rabid marketplace evolution, or in some cases revolution, where industry leaders are snapped up by other companies and then their offerings and availability changes. And you have to be able to negotiate those changes in real time. You just witnessed that live in this class. So instead of the parent company access data, now it's Exaro or something like that. We just had it on the screen. Describe the steps to prepare for acquisition. That's what you're walking through as you complete the assignment and begin your solution. Identify and assess legal and ethical issues present for the case. You had a taste of this in Intro to Cyber as well. It's good practice and it's important to go ahead and begin walking through it again. It needs to be reflex by the time you get out there in the workforce. You're going to list and describe tools used for data acquisition, including any prerequisites and caveats. Is free okay to use for data acquisition? Let me ask the question. Is a free product okay to use for acquisition, for data acquisition? We were using 4.6. Now it's 4.7.1. What would I need to do before I would have confidence in using a free tool like 4.7.1? Now that the version has changed, the company has changed. I would probably want to do some calibration and testing, right? I'd want to do some trials with it to make sure that the 4.7.1 works as advertised, works the same in the same manner. You have to be able to prove it in court. If this goes to court and Sydney Corinth decides to sue you into the Stone Age because you are the forensic expert who says Sydney Corinth is a bad person, Sydney Corinth is going to come at you with both barrels. You need to be able to show we were using FTK Imager version 4.7.1, and the attorney for Sydney Corinth is going to go, yeah, but that's a free product. Well, as long as we have validated the outcome with what? Readily supported open source products like Imager, right? We validated outcomes with a series of trials. and then used it with copies of the original data, right? So you can thumb your nose at Sidney Corinth's attorney. But the caveat is, if you have a new version of a tool, you better put it through its paces. You better make sure and validate, right? Validate, verify, authenticate all the time, have to be able to prove it. Given a scenario, compare and contrast digital acquisition tools and methods, select and use one. Provide best practice criteria and ordered steps to use a tool, perform an acquisition. That's in the solution. List digital evidence storage formats and the procedures for storing digital evidence. Explain the value. You're going to be walking through some of those procedures. Explain the value and relationship of the metadata for a given data file during acquisition. And so I actually have a screenshot of, I think it's an ISO file or another container file. The metadata changes, but the hash doesn't. And that's kind of freaky. So those are special cases you want to be able to explain. All right. Describe how to validate data acquisitions. Perform the validation of data acquisition. That's exactly what we're talking about. What do I mean? In our all right. So the hash does not match. Okay. Here we have two files, one called sandisk.vhd and one called usb. They're identical, they've just been renamed. What happens is that you can rename a file and the hash does or doesn't change, which. But if you go into one and add a document or change one bit, then the hash changes. You want to be able to perform the same tasks and understand the limits of your hashing tools and hashing scenarios. Let's demonstrate. Okay. Can everyone see my screen?
Yeah, we can see it.
Okay. Now, I'm going to go ahead and I'm going to generate a hash of this like I did just a moment ago. And yeah, it's so weird. Recent hash tool. So I'm going to select a file again in the temp folder. And it's going to generate a result in just a second. Hash 256 was already queued up. There's my hash. Okay. Now, this file is attached at the moment, right? Does everybody understand that? This file is actually drive letter what? F. Does everybody understand what I'm doing here?
Yes.
I'm going to copy this and I'm going to paste it. I'll put it in the same directory because I want the path to be the same. C:\temp. And I'm going to paste this, and I'll give it the name SanDisk. I need a prediction. Is the checksum the same for both of these files? What do you think?
I'm gonna go with yes.
Yeah, the size is 1,073,742,336 bytes. Same thing right here. Okay. Now, I've changed the name. It's in the same path. It's in the C:\temp directory. So it's in the same path. And it's just a file name that's different. Am I going to have the same hash result or a different hash?
You should have the same hash result due to them being the, what do you call it? Due to them being copies of each other.
Okay, let's find out. Interesting.
Digit for digit.
We talk about metadata, we're talking about the other attributes the file system uses to track a digital data file. Those attributes are stored in the operating system on the host computer. Put another way, that metadata is associated with this file. If we copy this to another file system or put it in another directory, we could end up with different metadata, but what we want to do is establish whether or not something's changed inside. All right, so here's what I'm going to do. I'm going to, what would be a good iteration of this process to see how far the hashing tool can detect changes? I have a copy of the same file named differently in the same path in the same directory. What would you propose?
A different directory.
Yeah, let's do that. I'm going to take this and I'm going to copy it. I'll put it in the VHD directory. Everybody with me?
Yep.
Now there's a different path. Predictions, same hash, different hash.
Same hash. Still a copy.
My point is, do you have confidence enough in your forensic tools to affirm and assert on the witness stand?
Let's go digit for digit.
Yeah. Okay. And I want you to understand that USB is already, it's attached as a drive, as a separate hard drive. So this one's actually in play with the operating system where it's accessible. I can click into this and, you know, I can attempt to change stuff. Do I have confidence in the read-only capacity of the operating system to prevent a change to the drive. Can I prove that? Well, let's try it. The point is that you're always in a state where you need to speak with confidence because you are the forensic what? Expert. You got to act the part because you are the part. Do you see an option to create a new here?
No.
I don't. How about if I try to drag and drop something in there? Let's get nasty. I'm just going to open up File Explorer here. And in my temp folder, I'm going to create a new text file called Hit Me. And I'll actually put something in there. Ouch. Right? So I'm going to save this. And wait a minute. No, I'm not gonna save that. I'll just don't save. Okay. So now in the temp folder, I should have Hit Me, right? Oh, where was I? I was back inside here. Let's see if I can drag Hit Me. Copy to SanDisk. Doesn't look good, does it?
Yeah, that was what I was expecting as well.
Right? Right? Verify, validate, authenticate. Got to be able to prove it all the time, all the time, all the time. Now let's get interesting. Okay. I have a forensically sound copy of this in the VHD folder. I've proven that if I move it to a different directory on the same disk, the hash is the same. What have I not proven? Have I proven that if it's on a different disk altogether, it'll still be the same? No, I have not. Prediction, different drive letter. Same hash or no?
Ooh, it's a different drive file entirely.
Yeah,
I'm gonna go same hash, it's a copy.
Yeah, I'll go
1,000
same hash as well.
points. 1,000 points. Same hash, it's a copy.
no, a file system can be corrupted. A file system can be unreliable. A file system can screw things up. Why do you use a forensic tool to create a forensically sound copy of a disk instead of just dragging and dropping and copying? Because you're going to find cases where the activity we've just performed doesn't produce the same result. I'm working on a brand new laptop. I mean, it's like 2 months old. It's 60 days old. It has a NVMe, a very fast hard drive, right? And the point is that sooner or later that memory media is going to become faulty and I may not get the same result over time. Everybody's rate of data integrity starts to change at different rates on a different timeline, depending on a variety of factors, environmental conditions, the stability of the electrical grid, the abuse of the user, right? All sorts of factors. What you're seeing here is an ideal case. Now, what I want to do is I want to attach this VHD, and I want to change one thing. Okay. So I'm going to take the E drive SanDisk and I'm going to connect it, but this time I'm not going to connect it as a read only. Everybody with me?
Yep.
Action, attach VHD. I'm going to forget the read only piece. I'm gonna go into the E drive. There it is. Everybody see that? Does it make a difference if this is attached versus here's another question. What happens if I hash the drive letter instead of the USB? Does everybody understand the question? Nobody's gonna take a chance, huh? I wanna see if after I attach it with read properties enabled, whether or not that's changed anything on the disk, okay? Prediction,
Okay.
same hash,
Mm,
different hash.
it's a copy. I'm going all in. Same hash.
Same hash.
Innocent until proven guilty.
Okay, that's E drive. We've connected it. Now it's in the file system, has a disk. Uh-oh. What the hell? Not sure we did that correctly. I'm in the E drive, VHD, SanDisk. Ooh. Explanation. What's going on here?
No idea, actually.
Let me try to connect to the temp folder USB, right? Because we got a clean hash there, right? Does everybody understand what I'm doing here? That's my original USB, isn't it? Before I made a copy and then changed the name. Well, let me try it again. E drive, VHD, SanDisk. Error. Wow. Okay. Now I'm creating a hash of the VHD file itself. In theory, the VHD as drive letter E should be the same as drive letter E should have the same contents as VHD. Wouldn't you agree?
Yep.
Okay. So I'm going to take drive letter. Let's see. What's our first drive letter? The first drive letter that we created by attaching the SanDisk, the VHD, was SanDisk drive letter F. And that is the VHD in the temp folder on the C drive. It is a write protected copy. Okay. Everybody with me? So as far as a data object, do you think that if I create a hash of drive letter F, that's going to be the same as creating a hash of the VHD? Predictions.
Ooh, same hash. Should be. Or my error.
Anybody else?
I think same hash as well.
Everybody see what I'm doing now? I've gone up in the tree. I'm connecting to drive letter F. I want to hash drive letter F. Actually, let's do that again. I'll select this and say open. Oh, it wants to go. It won't let me select the drive letter as if it were the whole disk, right? What do you think is going to happen when I take Geimager or I take FTK Imager and I point it at this disk like it's a physical hard disk? Do you think I'm going to get the same hash SHA-256 that you're seeing right now over and over and over again, ending in 5 Charlie 7 2 Echo Echo? You think I'm going to get the
No.
same?
Nah, because it wouldn't be of the same file type. I mean, not file type. The original USB.VHD contents won't be pretty much. There would only be a small trace of it found inside of that, if at all. So because their contents are different, you wouldn't have the same hash. Or that's the theory, anyways.
That's interesting. So you're going to get a chance to find out. You can generate SHA-256 results. And maybe because we've been doing that all day long here, we should update or revise the solution so that everybody consistently generates SHA-256. What you may find, though, is that in different operating systems, hard drives or disk volumes come with their own baggage, so to speak. So forensically speaking, a disk volume in Linux or on a Mac or in Windows, in order for the file system to view and access that storage object, there is extra attributes. There are additional attributes that come into play. For example, the method of initialization. It could be GUID, or it could be an old school legacy MBR initialization in terms of the partition that's configured upon initialization. The partition itself, whether it's a primary or an extended, whether it's active or not, whether it's bootable or not, those are additional attributes that, depending on the hashing scenario, you can get different results. I want to take one more moment to do one more thing with the readable version. Okay, so in this activity we have 2 identical copies of VHD, one that's write protected, which can be hashed. Because it's write protected, it can't be changed. The other one is open because it is write enabled, and therefore the operating system is treating it like open media, ready to write. Put another way, I have it open in File Explorer. What would happen if I closed out my File Explorer so it's not open in File Explorer? Could I get a hash then, even though it's, see, I pulled properties as well, right? So you know what happens when you have things open in a system, right? Everybody with me on that? When things are open in an application, when things are open, hello, we're almost done. When things are open in an application, that means that the file is locked because the file system doesn't want multiple changes, right? Have you ever tried to like copy or paste something and it says, hey, the file's in use, you can't do this, or something like that? You know what I'm talking about, don't you?
Yes.
Yep.
Okay. All right.
Yeah, I always wondered like why it even said that.
Because the file's in use within a file system tool or utility like File Explorer. Okay,
Okay, so then that means that while, like, as long as a file is in use somewhere on the computer in a program, you quite literally can't tamper with the components live.
yeah, and the fact that I've closed File Explorer completely does not mean, oh, here's where it's also in use.
Ah, okay.
So let's do this. I'm gonna
So
close this.
wouldn't that like so wouldn't that also be like a great what do you call it? That would be like a great forensic thing to know, because if we were to go onto a live machine and we try to what do you call it? We try to access a file, or we try to change the components of a file and we realize that it says, oh, the file's in use. Much like with the Sydney Corinth machine, sometimes it could literally be in use by things we just can't see in the foreground because they're hidden in the background.
Exactly. The point we're making here is when you get to the place where you're doing incident handling or the first stages of data acquisition as a digital forensics expert, you're the specialist. Doesn't matter if you're DEFR or DES. You want to make sure that you understand exactly how your tools work. You want to be able to state with confidence on the witness stand in every single scenario what is and isn't. And you want to be able to duplicate the results, demonstrate the results. Claim here, allow me to demonstrate. Oh, no, that won't be necessary. Thank you very much. Right? Oh, we have our own digital forensic expert. It doesn't work. Oh, that's because you're doing it wrong. You have the darn thing open in File Explorer. Duh, right? Okay, you want to be the expert because you are the expert, because you took the time to investigate. Now we've closed those. I want to see if we're going to have an error on this or we can get an identical read. We haven't changed anything yet. So let's repeat the same failed and see what happens. Now, sometimes when you close an application, in the background, it's still in there, right? So if I go into Task Manager, I might find an instant of File Explorer still operating in Task Manager because I don't know, because Windows is kind of stubborn sometimes and it likes to multitask and it likes to keep things handy, right? It's juggling and multitasking. I don't see anything that could be running here. So, all right, let's do this. I'm going to select one more time. Drum roll, please. It's the F drive, isn't it? No, it's the second one. No, no. I'm sorry. What was I trying to do? I was trying to open in the VHD the SanDisk. All right, that's what I'm going to do. In drive letter E, here it is. In VHD, here's the SanDisk. Everybody see this? Oh, it's taking longer. Oh, it's taking longer. Oh, it's taking longer. Wait for it. Wait for it.
This is it. This is it.
No, it's another error.
Ah,
It's another error.
Is the error showing? Oh. Mhm.
Another error. So, well, let's do this. This is write enabled now, right? Absolutely last thing. I can make a change to this. I'm going to create a new text document. Everybody see this?
yep.
You know what I'm going to do with the name? I want to take out I want to rename it. How much do I have in it? 0 bytes, right? What I want to do is rename it. Let's see if I can do this and just put a null entry. like a non-printing character or something. I'll just put 0. Okay? Because if I don't put something down, then the file name won't take. So I have 0 bytes in here, and the name is 0.txt. If I have null bytes, that means the only thing I have is a file in here with metadata for the file. But I don't have anything in the file, so I don't really have any 1s or 0s added. Is everybody with me? I have a file system object in here, but there's nothing in it. It's empty. I'm going to refresh this just to make sure. No, still the same, right? So the only thing I have is file system metadata, but there's nothing. It's an empty file. Okay? Does everybody understand what I'm doing here?
Mm-hmm.
Okay. Now what I'm going to do is I'm going to close this, and I'm going to go into here, and I'm going to eject this G drive because it's the readable version. Okay? And prediction. Hash different, hash same.
Hash different.
Yep, different.
You are so confident.
Different.
Hash different. Even though I
Yeah,
have
I'm
an
gonna have to say
empty,
different.
is my properties the same? Wait a second. This one. Are my properties the same? Do I have the same checksum?
Oh, I thought you were gonna test out the 0 file.
I am. This is our original, isn't it?
Yeah, that's the original.
This is the original.
Yeah, that's the original. Yeah, they're going 1 for 1 in byte size.
Nothing's changed yet, right?
The
Size on disk is different.
The size on disk is different?
yeah, the size on disk is different.
Really?
Yeah.
Yeah, but it's on a different physical hard disk. So I could have a
Yeah.
size on disk difference that I could account for simply because it's, let me see that. Oh yeah, good catch. Size on disk is different. That could be a factor that's related to the media. I have 2 different brands of NVMe, right? I have two different M.2 NVMe drives. So the size on disk could be different because of the way the stuff is written to the physical hardware. I don't think so though. Oh, the size is the same, but the size on disk is different. That might be a telltale sign. Prediction, same or different?
Different.
Everybody's confident, right? Well, let's see. If you were on the witness stand in a courtroom,
Your Honor, my client was in fact correct.
adding a file that has 0 stored in it will modify the ISO. Do you have confidence in this hashing tool? Well, if you verified it with other hashing tools and that was the same outcome, you could definitively prove in a court of law that you have confidence in your tools, that you have validated how it works under what conditions. And no one would be able to challenge you as far as now. There are finer points to this, and I'm sure that somebody that does this for a living could say, Professor Kentop, you're oversimplifying. Yeah, okay. Well, for the purposes of academic scenarios, the point we're trying to make here is you always have to be able to validate, verify, authenticate. You're calibrating your tools constantly. You have to be able to prove it, prove it, prove it, especially when tools change. When the version of the tool changes, when there's an update to the tool, every time the tool is updated, every time there's a bug fix or patch for the tool, every single time, because you don't want to find out in a court of law, well, that there were errors. Okay. All right. So this concludes our session today. Thank you for joining us. Please be sure to complete the 3.2 assignment by the end of Saturday, 11:59 p.m. Saturday, and by the start of our class Tuesday morning, this time next week, 9 a.m. for the solution. We'll review more content in our, we'll pick up the pace considerably on our Module 3 content so that we cover all of our student learning objectives. Please try to read ahead if you can, and we'll see you then. Does anyone have any questions or comments or observations based on the material presented today? Okay.